So I asked for the lectures and your material and whatever you have been told. So first tell me, what is the exam about? Is there any direction your professor has given to you? Like any sample test or sample exam? Just recommended problems from the book. It will be 6 questions from the recommended homework. Fine. So I asked again and again. So tell me what is professor has told them in the class, but they didn't tell me anything. 5 will be from chapter 9. Okay, from the homework.
You were asking about what the professor said?
Yes. I want to know what professor has given you directions, how they will be examined like that.
6 questions, one of which will be from topics of before the midterm. The rest will be for topics after the midterm. And it'll be 6 questions from the recommended problems from the textbook, which I believe is edition number 7 of
Chapter
the
9.
of the textbook. That's all he said. He hasn't given us any sort of practice exam or anything of the sort.
So
But if what he said is true, then technically us doing the problems from the book should be enough, technically. But I have no
the
guarantee.
midterm, it was enough?
The midterm, let's just say that I think we'd all prefer not to talk about the midterm.
Okay. Okay, let's not talk about the midterm. So, okay. So I have few questions from the final exam, which was given in the fall 2016. I have prepared those because I did not know that you have some recommended problems or some this information which you have just gave me. So we will discuss. They are from chapter 9. And chapter 9 is about line integrals and volume and the volume and the divergence and curl, etc. Vectors, yes.
So yeah, is everything from no wait, not Laplace.
Yeah, send me.
Give me a second. It's the Fourier. No wait, it's. I'll get back to you. Give me a second.
Okay, the thing is, I'm not your TA, fine. I was not in the, I don't have the access to the course. Otherwise, it was very easy for me.
Okay, so it's Fourier series onward.
Fourier series onward, okay. So can you send me the problem so I have a good idea? Otherwise, I have the prepared the solution for the fall 2016 final exam. Hopefully, it will cover everything you are saying to me. So we can go to that and we can discuss everything.
How do I send this to you?
Sorry?
How do I send this to you?
Okay, send it to me.
The list of recommended problems.
Okay, send it to me by email.
Okay, give me a second.
Yes, I will explain. Don't worry, I will explain it. Find the directional derivative. So this is very small. I can't read it. Let me download it.
Okay, I sent it in the chat. MT through 12 recommended problems. You'll need the textbook to actually do the recommended problems though.
You send it to me where?
The chat.
In the chat. Okay, I got some. This is, yeah, I got it. Thank you very much. So chapter 9 is, the section 9.15 is very important. Okay. So. Let's see. So work done is in the chapter 9. Fine. We will start with the work done. Is that okay? Fx, y, z is equal to this one, r is equal to, yeah, these kind of questions I have and I will do it with you. But the thing is, if you ask me to do these questions, which are you are showing me now, it will take much larger time, but you want to learn the technique, fine? So,
Yes, please.
yeah, so that we will do the final exam of 2016. It came in fall 2016. I have it, and we will do it because it covers the same material. So it will help. So should I start? Okay. So I'm going to share my screen with you. Yeah, there is not, this is my handwriting, which is not very beautiful, but accept it. So first question we will go through is chapter. Yes. Is there any question? Okay, let's start with work done. Find the work done. We have to find the work done by the force F, which is equals to minus x square y I unit vector plus y square x why it's not writing. J unit vector. And we have along the closed curve formed by, so we have a curve which is formed by the y is equals to 0, x square plus y square x square plus y square equals 16. Y is equals to x, and the pen is giving me a very hard time. Okay. Give me 1 second. For the solution. So x squared is equals plus y squared is equal to 4. Yes, I will post this recording on the NUES, inshallah. So if we look at it, these are this is our curve. And we have to assume counterclockwise direction. I will send the notes as well as the link to MUS. Counterclockwise direction. So this is our problem. This shows a curve. This shows the boundaries. Fine, this curve. So if we draw it, let me move it up. So we have x is equals to 0, y is equals to 0. Y is equals to 0 is along x-axis. It is 2D. So this is y is equals to 0. Then we have x squared plus y squared is equals to 16. So it means that we have a circle of radius 4. Right? 1, 0, 1, 2, 3, and 4. So this is the circle which is going up. And here is our y. Let me make it green so that this is our y. 1, 2, 3, and this is 4. And then we have x squared plus y squared is equals to 4. It means we have a circle which is of 2. Fine. Yes. It is going to count. Just 1 minute.
Hey, Alex, mute yourself.
Yes, please keep your self mute. So we want to, where I was, x is equals to y. So this is our x is equals to y. When x is 1, y is 1. When x is 2, y is 2. And so on. Third is, we are done with our boundaries. If we look here, y is equals to 0 is this line. And then we have y is equals to x, this line. And then we have circle of radius 4. And we have a circle of radius 2. So you got it. And now we have direction counterclockwise. This is counterclockwise direction. Any question about this diagram? No question? Everyone is good? So we have 4 curves here. Y is equals to 0 horizontal because this is XY plane. We are talking about X and Y variables only. So it is 2D plane. And when we talk about Y is equals to 0, it is given to us in the question. So it means that we just take the x-axis. Okay, thanks. Fine. Welcome. So I will send you the notes as well. Any other question? So you can ask me the question that we can extend it. Fine. We can extend all these lines. So why can't we consider these circles? You should ask this question. Because we are not considering this because we are told that direction is counterclockwise. So in this direction, this is going clockwise. So that's why we are not considering it. Now we have curves. So this is C1. This is C2. This is C3. And this is C4. So now we have the diagram. We can work out solution. So let's write blue. F dot dr is the work done. And it will be going to be F is minus x square y unit vector I plus y square x unit vector j. dr is dxi plus dyj. So our f dot dr will give us minus x square y dx plus y square x dy. Till here good? Okay, you are with me. Okay, great. So we have to calculate this one. Yes, any question?
Sorry, we're using polar coordinates in this question, right? Because you're using dr.
No, I'm not using polar coordinates. Why you are using polar coordinates?
I don't know. I just assumed. Sorry, my bad.
Okay. Now, first curve was this one. Fine. This is our C1. Y is equals to 0. dy is equals to 0. Okay. So we have work done at C1. Let's say it is I1. Don't write this one. So this is our I1. It is going to be minus x square y dx plus y square x dy. And we are calculating it on C1. So it is because y is 0, this is 0. And dy is 0, this is 0. Y is also there. So it is 0. Then we go for the I2 second curve. So I2 is going to be C2. We have,
Sorry, just a quick question for I1. Why are they both 0 again? I missed that.
because y is 0, dy is also 0.
Okay, thank you.
Welcome. So here we have in the C2 curve, we have, this is our C2 curve, which is going like this. It is x square plus y square is equals to 16. Okay, means a radius is 4. So when it is 16, this means here we have x is equals to y. So it means I write it x square is equals to x square plus y square, sorry, x square plus x square is equals to 16. This implies x square is equals to 8, which is means x is 2 under root. So our top limit is 2 under root 2. Our lower limit is 4. X is 4. Fine. So let's do it. C2 is minus x square y dx plus y square x dy. We can calculate the value. Let me write it in the other color so it will be separated. So we have x square plus y square is equals to 16. We will convert it into the x variable term so that we don't have to worry much. So y square we can write 16 minus x square. So this is 16 minus x square and this is y, and y will be 16 minus x square under root. Let's put the values. We got, here we have limits and here we have term, fine, in the x term. Now we will solve it. It will be easy to solve in the dx format. So we will become, curve 2 will become 4 to 2 under root 2. Okay, let me, 4 to 2 under root 2. And then we have minus x squared multiplied by y, 16 minus x squared dx In the second term, we have x y squared into x, and dy we didn't consider yet. So let's find the dy. So whatever we do, we have to be very careful we don't mix it. 1/2, 16 minus x squared minus 1/2 multiplied by minus 2x dx. So in this format, we have dy. So here, sorry, we will write, this is cancelled. We have minus x over 16 minus x squared dx. So now we have term in the x format. So it's easy to handle. So minus x squared, both terms have minus x squared, both terms have dx. So 16 minus x squared under root plus 16 minus x squared. So this is 4 to 2 under root. So these are adding, so it is minus 2x squared. Both are minus, so they will be added. It is minus 2x squared. And 16 minus x squared will be common. Oh, so this is not correct. This should not be here. This is the term we are left with. Any question till here? So when you will solve it, you will get to 16 pi answer. This is just the integration. You can do it in one variable integration you can do by yourself. For the boundary, how did you find the x upper bound again? Did you equal y is equals to 0 to find it, and lower bound 4 is because it is radius? Does the radius of similar questions always become the lower bound? First thing, it is not the radius will become the lower bound. So let's go back to the curve. We look at the curve, okay? This is our curve. So let me make it red. So this is our line. Oh no, sorry, man, I deleted it. This is how to do undo. Let me do it again. This one goes like this. So this is our curve, fine, this one. It is starting from 4, it is going up, so this is upper bound, right? So we have to find this value. This value is on x is equals to y. So we will put x is equals to y in this equation, and we get the value x is equals to 2 under root 2 at that point. So here x is equals to 2 under root 2 and y is equals to 2 under root 2. This is the point. Any other question? Okay, now we will solve this next part. So I3 will be 2 under root 2. We know it starts from 2 under root 2 and it goes till 2 under root. And minus x square y dx plus y square x dy. So x is equals to y for this curve. So put x is equals to y, we have minus x cubed dx is equals to dy. So minus x cubed dx plus x cubed dx, it is equals to 0. Now you will ask why it is 2 under root 2. Fine, you will ask that. You should ask if you don't ask. So this is the curve we are talking about. This one, fine. So here it is 2 under root 2 and here we have the radius 2. So here, x is equals to 2. So it is the radius 2. So let's go back. Y, the limit is 2 under root 2. So x squared plus y squared is equals to 4. X is equals to y. So x squared plus x squared is equals to 4. 2x squared is equals to 2. So this means x square is equals to 2. So x is equals to 2 under. So we got the limit. Fine. X square plus x square is equals to 16. That was for the previous curve. We are talking about the third curve, which is ending at, look here again. This curve is starting from this circle and ending from at this circle. Okay. So here radius is 4 and 2. But what is the value of the x and y points here? We have to check that. Radius of a circle is, this is circle of radius 2. It does not mean here x is again 2. It's not 2 here. It's a different value. This is 2. You got it? No? Ask me if you have question, ask me. So this is the x point, fine. This is the y point. This is the y point here. You see, they are inside the circle. They are different from the radius. So radius is from 0 to that point is the radius, but these are different points. So this point is different for x and y. Hopefully you got it. Okay, now we will go for the curve 4. So curve 4 is this one. Here it is 2. Here it is 2. Okay, so this is the C4. So here we have found that this is 2 under root and this is 2. So this time our boundaries are already mentioned. So we are going for I4. Sorry, I should take it blue. I4 will be, it is finishing at 2. It is starting from 2 under root. And then we have minus x square. Let's take y is equals to x square plus y square is equals to 4. So it will become 4 minus x square and square root. So 4 minus x square root dx plus y is 4 minus x square. Y square is 4 minus x square multiplied by x multiplied by minus x over 4 minus x square dx. So this term is equals to dy. So any question till here? Okay. So then we will solve it and we will have minus 2x square 4 minus x square the root dx, and it is going from minus 2 under root 2 to, no, not minus, plus 2 under root 2. And solving it, we get minus pi. So our work done is equals to I1 plus I2 plus I3 plus I4. So it will be equals to 0 plus 16 pi plus 0 minus pi, it is equals to 15 pi. So any question about this problem? After this, we will go for the, this was easy question. Stokes theorem is included in your material or not? Say it
I
again.
believe so.
I could not hear you guys. Let me put my
I believe so. It should be included.
Say it slowly.
I believe so. Stokes' theorem should be included.
Stokes theorem is included. So Stokes theorem is easy. Do you want me to do it for you? There is a question with Stokes theorem here.
Sure.
Sure.
The more practice, the merrier.
Sorry?
Sure, the more practice, the merrier.
Okay, so let's do the Stokes theorem. Fine. So this is the question, same question they give in with the Stokes theorem and with the line integral. So if they say use it Stokes theorem, then use it. If they say don't use Stokes theorem, then it means you should not use the Stokes theorem. So be careful about that, otherwise you will lose the marks. So line integral we will do later, but first we do the Stokes theorem. Okay, Stokes theorem question. In this question, we have given the integral. We have to find f dot dr. We are given f. F is x plus 2z I unit vector. Okay. Plus 3x plus y j unit vector plus 2y minus z k unit vectors. This is our RF, and C is the curve. C is the curve of intersection of the plane is given by x plus y plus z is equals to 1 with the coordinate planes. So we have to solve it. So let me write it blue. Blue is better. You know Stokes theorem is f dot dr equals curl f dot normal vector ds, and this is our surface. So first we find the curl f, which is very easy. Write I, j, k, partial over partial x, partial over partial y, partial over partial z. Second row. Third row is going to be the our parts of f, which are given here. This one first, second, and third, I, j, k. So x plus 2z. Y is 3x plus y. And z, k unit vector is with the 2y minus z. So this is our curl. I will just. So we will find this curl. This is I unit vector. So we have 2 minus curl over curl z 3x plus y is 0 minus j unit vector. Curl over curl x into 2y minus z is 0 minus curl over curl z multiplied by x of x plus 2z, it's 2. Plus k unit vector, we have curl over curl x 3x plus y, so it is 3 minus 0. So I say curl, you can say partial, so don't get confused, it is the same thing. So we have 2 I unit vector plus 2j unit vector plus 3k unit vector. This is our curl f. Now we have to find, we have the curve of intersection. For that, let's define our function g, x, y, z, and we make our plane in it, x plus y plus z is equals to 1 minus 1 equals 0. We will put this, we will make it function of x plus x, y, z. So let's calculate the gradient of g. This is going to be curl over curl, partial over partial x, g plus partial g over partial y plus partial z over partial g over partial z, which is all equals to 1. So we have with I unit vector, j unit vector, and k unit vector, we have I unit vector plus j unit vector plus k unit vector, and the mod of gradient g is going to be 1 plus 1 plus 1, so it squares 1 square is square, again 1, so it is 1, so it is equals to 3 the root. Normal vector is gradient G divided by the norm of gradient G. So we have 1 over 3 under root I unit vector plus 1 over 3 under root j unit vector plus 1 over 3 under root k unit vector. So now we have normal, we have f. So our curl f dot n is going to be equals to 2 by 3 under root iota I vector. No, it is dot product, so I will be gone, plus 2 over 3 under root plus 3 over 3 under root. So it is equals to 7 over 3 under root. So this is our, now curl f dot n, we have to calculate over the ds. So this is our curl c. So we have 7 over 3 under root. This will become c and ds. So this is now simple. We have simplified it. Your professor have given you formulas in the lectures. So in that case, our ds will be equals to 1 plus partial f. So first we will define. So let me define. So our x plus y plus z minus 1 equals 0. Fine. This is our g, x, y, z. So if I take z equals x, what happened? Okay, z will be equals to 1 minus x minus y. So it is a function of x, y. Now you can write it in 2D terms. So we will have our ds will be equals to 1 plus partial f over partial x square plus partial f over partial y square under root. And we will apply the values here and we will get, this will be equals to partial f over partial x is minus 1. Partial f over partial y is also minus 1. So it will be equals to with dA. So it is equals to 3 under root dA. So we can write it in our terms. We have 7 over 3 under root multiplied by 3 under root dA. Here we have our R. Now we have to see the limits, how we will apply the limits here. So for that, our fxy is equals to 0. We have fxy is 1 minus x, 1 minus x minus y is equals to 0. So if I put x is equals to 0, it means y is equals to 1. And if y is equals to 0, it means x is equals to 1. So now we will look at our function. Sorry. This is the terms. So draw our 2D. This is our x. This is our y. When y is 0, x is 1. When x is 0, y is 1. So this is a triangle you are looking for. So the area of the triangle is your dA, which is equals to 1 over 2 into 1 into 1. So it is equals to 1 over 2. So we have 7 over 3 under root multiplied by 3 under root multiplied by 1 over 2. This is equals to 7 over 2. This is the answer. Any question? You got it? It makes sense? Okay, fine. So now, do you want to solve it with line integral? If you want to solve it line integral, it is the same question. No answer? Can you do Green's theorem? Green theorem. Oh, there's no question of Green theorem in this paper, which I looked into it. So send me the question, I will solve it for you and I will send it to you, okay? So the questions which I have, I can tell you. One question is iterated in integral and the surface tangent plane. And next question is work done by the force. And the interesting question is find the volume of the solid.
I think so we can solve, find the volume of the solid one.
Find the volume of the solid one. Okay, fine. So this question.
And then we can solve line integral.
Okay, fine.
Thank you.
So this is the one we have. So this is question number 9 in that paper. Find the volume of the solid. That is bounded by the graphs. Okay, this is a little bit tricky and you have to understand the figure. That is bounded by the graph of the given equation. Okay, so equations are z is equals to x square plus y square. 2z is equals to x square plus y square plus 4. And x is equals to 0 and y is equals to 0. So this is the question. We have to find the volume. So let's draw the figure. So this is our x-axis. This is our y-axis. This is our z-axis. Now look at this one, x squared plus y squared is equals to z. So let's try this one. So when x squared plus x and y are 0, z is 0. So this is the point. When x squared plus y squared is equals to z1, so it means it is a radius of 1. So it is going to be like, because it is 3D. So this is going to be a circle of, top is circle of radius 1. When z is 2, it means top of is 2 under roots, radius 2 under root. When z is, radius is 2, and so on, fine. So it will go like this. You got this point? Till here you got it. Now we will look at this one. It says z is equals to x squared plus y squared divided by 2 plus 2. Fine. If x and y are 0, we have point here at the 2. Z is 2. This is when x and y both are 0. So it starts from here. And now its values increases. When I take x squared plus y squared is 1. So it means z is equals to 3 by 2. When I take x squared plus y squared is equals to 16, it means it will become 10. And so on. Fine. And so on. So it is going like this. It is shallow and it is getting bigger. So it is like you have a cylindrical thing, and then there is a like you have a glass and you put a plate on it and to fix it. So it is like that. So this is the one. which you have. And now this is the point of intersection, right? Where these two curves are meeting in each other. So let's go and find that. What is the point? So z is equals to x squared plus y squared equals x squared plus y squared divided by 2 plus 2. So this is our z and this is our z. Considering we get x squared plus y squared is equals to 4. So our radius is 2 here. And z is 4. So here, where z is 4, our radius is 2, and we have intersection. So till here you got the diagram. Yes, great. So now we have x is equals to 0. If x is equals to 0, this one, if x is equals to 0, so it means we are talking about yz plane. If y is equals to 0, this means we are talking about xz plane. So yz plane, if I draw here, with which color I should draw it. Let's choose some nice color. So let's take purple. So this is YZ plane, fine. This is YZ. So here it cuts it. This one. And then we have plane, which is x is equals to 0, it is y xz. So this is circle, this is our x. So this plane will go like this, which is cutting it. So we are left with, let me take some other color. This one. So this is the area. This is what we are left with. And we are talking about this area. So it is going to be like this. And it is going to be like this. So this is the area we are talking about. This is the volume of the solid we are going to find. Okay, now any question? We can solve without diagram, right? So I don't know. Okay, when we see the diagram, we can solve it using, we can solve it using polar coordinates, as well as we can solve it using coordinate axis. So which one you want to solve it? I choose x is equals to 3 by 2. When did I choose x is equals to 3 by 2? Oh, this one. You are talking about this one? So I was saying that if this term is 1, then it is 1 by 2 plus 2 z is equals to 3 by 2. I was just trying to explain that how the figure will emerge. So let's solve it with polar coordinates first. And if you want, we can go for the axis as well. So polar coordinates. Just 1 minute, I mix up my papers. 1 minute. Yeah. So in the polar coordinates, we have x is equals to r cos theta, y is equals to r sin theta, and z is z, right? And we have dx dy is equals to r dr d theta. This is polar coordinates. Now looking at the curves which are given to us, this one, how do you see that? This one, which I'm talking about. So z is equals to x square plus y square. So z is equals to, we make it blue. Z is equals to x square plus y square. So in the polar coordinates, it will become r square cos square theta plus r square sine square theta, and it is r square. Fine. So z is equals to r square. For the other curve, we have z is equals to r square divided by 2 plus 2, because it was x square plus y square divided by 2. So z is equals to r square by 2 plus 2. Now we have to check when z is 0. So r is 0. Okay. And theta is 0. If we look at the figure, we can say our r is from 0 to 4, because z is maximum 4. And our theta goes from here 0 to pi by 2 at the most, because we are considering this part. So it will go from 0 to pi by 2. So r is going from 0 to 2. Sorry, it is the circle is 2. Sorry. So a circle is 2. So it is going to be 2. Radius is 2. So when r square is 4, so r square was 4. So it means r is 2. And theta is going to be pi by 2 maximum in our quadrant. If we consider the other quadrants, there we will have negative values. It will become complex and we can't find the intersections and etc. other things. So we don't consider that. So we have r is equals to 0 to 2. Theta is equals to 0 to pi by 2. And our values will become r dz d theta dr theta dr. This is our values in the 3D. So we have, putting the values, r is r, z is going to be r square by 2. Did I write it first or not? No? Okay, let me write it. dz is dz, so r squared by 2 plus 2 was the last boundary of r. Okay, I made a mistake here, so let me write it correctly. So here our z is going to be from r squared to r squared by 2 plus 2. So first we will solve z, r squared to r squared by 2 plus 2. And then we have theta and we have r here. We are solving r dr d theta here. So z will become r squared by 2 plus 2 minus r square and r dr d theta, and here they are. Now if you look at, r does not depend on theta, so we can solve them separately. So let's say d theta here 0 to pi by 2, and here we have r, so it is going to be 2 minus r squared by 2 r dr. You got this point? So it will be equals to, if they do not depend, you can solve them solve them simultaneously, okay? If they do not depend on each other. So it is pi by 2 from here, and here we have r is equals to 0 to 2, 2r minus r cubed by 2 dr. So let's integrate it. We have pi by 2, 2r square by 2 minus r cube, r4 divided by 8. And we are going from 0 to 2. So this is cancelled. We have pi by 2, 4 minus 16 over 8 minus 0, that is not, so it is 8 minus 8, so it is 2 pi. 4 minus 16 over 8 is going to be minus 8 and 4, so it is pi by 2, so it is 2, it is pi. Because it is 2, 4 minus 2. Yeah, pi. Any question? And it is done. This question is done with polar coordinates. If we go with the second coordinate axis, so if we use xy axis, xyz, then it is also possible to solve it. If you want, I can do that if you don't like the polar coordinates. So do you want me to solve with that? Yes, please. Okay. So we have the same diagram. X, Y, Z. Okay. So did I write? No, it is not 2 pi, it is pi only. God, I write wrong here. It is pi. Look, 4 minus 2 is 2. 2 will be cancelled. We have left with 4 pi. So we are going to do it again with the other coordinates. So let's say our x, z is z. So it is almost halfly solved. So we have to write our values. X goes from 0 to 2, y goes from 0 to 4 minus x square under root, and z goes from x square plus y square to x square plus y square divided by 2 plus 2. dz, dy, dx. Now you will ask me, how did you find these limits? So let's look at these limits before we proceed further. So y values we are given in the limits. Okay, so these are the y limits, and x square plus y square is equals to 4. So this is the xy plane. Fine. So if I put its shadow here, it will be in the xy plane. So in the xy plane, we have x square plus y square is equals to 4. This is, if I take y is equals to 4 minus x square, y square, and then in this part, and then we have y is equals to 4 minus x square under root. Y is equals to 0, we are given. You got it? And similarly, when we put y square, y is equals to 0, x square is equals to 4, so x goes to still 2. From here, this projection, we can write that. Okay. So I will write here, for limits, consider projection. In XY plane. Now we have to solve the, we have this, we have to solve it. So, why are you doing this? So, okay. Z, we have, so Z, x square plus y square to x square by 2. X square plus y square divided by 2 plus 2. And we have Let me write it again. It's just acting weirdly here. This is our x, this is our y. Z we are solving. X square plus y square, x square plus y square divided by 2 plus 2, dy dx. So this will become x square plus y square by 2 plus 2 minus x square plus y square, but that's it. And dy dx. Here we have y. When you write an exam, write all the limits carefully. So here we have 2 minus x square plus y square divided by 2. And we have dy, and then we have dx. Now y goes from 0 to 4 minus x square under root, and here is x. So 1. Okay. So we'll have y. So it is 2y minus x square y over 2 minus y cube over 6. And values goes from 0 to 4 minus x square. And dx is outside, and we are left with x is equals to 0 to 2. So now we will solve it and we will get pi. It's easy from here. Any question? So if there's no question, then we will go for the line integral. Welcome. So we will go for the line integral question. It is question 4 in that paper. So using the line integral, evaluate f dot dr, assuming C is oriented counterclockwise. C is oriented counterclockwise, and f is given to us as x plus 2z I unit vector plus 3x plus y j unit vector plus 2y minus c k unit vector. And C is the curve which is given to us. It's the same question which we have done solve with the Stokes theorem. But we are going to the coordinate planes, okay? So let's solve it with the line integral. So our C is our C is x plus y plus c minus 1, as we did already. And this is the function. So I is equals to our I is f dot dr, which we are going to solve with line integral. It is going to be f is given to us, so x plus 2z. dr is, okay, let me write it. 3x plus y j unit vector plus 2y minus z k unit vector, and it has a dot product with dr, which is dxi unit vector plus dyj unit vector plus dz k unit vector. And when we take the dot product, our unit vectors will be gone. So we will have x plus 2z dx plus 3x plus y dy plus 2y minus c dz. So this is our This is, let's say, integral 1, this is our integral 2, and this is our integral 3. Now, I did not discuss here, so let's discuss something here first. This is our C, fine. If I put, this is my x-axis, y-axis. If y and z are 0, my x is 1, fine. So it is 1, 0, 0 point. If x and z are 0, my y is 1, so this is 0, 1, 0 point. And if x, y both 0, then this is 0, 0, 1. So my curve is in fact this one. Okay, it is counterclockwise, so this is the direction. Now we have to go for this one. Did you get it, or I should draw it again? Should I draw it again? It's good, thank you. Okay, fine, great. So we have 3 curves, fine. So first curve goes from 1, 0, 0 to 0, 1, 0. This is counterclockwise. So it means here, my y goes from 0 to 1, z is 0 all time, y goes from 0 to 1, and x goes from 1 to 0. In the curve C2, we are going like this. This is the point 0, 1, 0, and this is the point 0, 0, 1. So here, z goes from 0 to 1, y goes from 1 to 0, and x goes from 0 to 0. In the third curve, I have, this is 0, 0, 1, and it goes to 1, 0, 0. So y is 0, z goes from 1 to 0, and x goes from 0 to 1. So this is, you should know, because we are going to use it in the solve. So now let's solve our problem. So our first integral is this x plus 2z dx. This is closed interval. So we will write it with the, curves. So this is going to be C1 x plus 2z dx plus C2 x plus 2z dx plus C3 x plus 2z dx. So here our C1 going from x going from 1 to 0, and z is 0, so x dx. Here C2 is going from 0 to 0, x is 0, so dx is also 0. And in the third curve, we have x plus 2, and z is 1 minus x, because y is 0, dx, and it goes from 0 to 1. We we have dx everywhere. So now solving it, we get x squared by 2, 1 to 0, plus 0, plus x plus 2 minus 2x, so it is 2 minus x, dx 0 to 1. Will the recording be available after this? Patel, I will give the recording to the MUS. You can check on their website. So it is going to be 1 over 2 plus, this is 2x minus x squared by 2. So applying the values, we get 2 minus 1 over 2. So we have 2 answer here. I hope I didn't make any mistake. Keep an eye if I make any calculation mistake. So for the I2, this is our I1. For the I2, we have okay. So let me again check I did correctly. Oh, it should be minus. Yes, so then it will be 1. I just had something is wrong here. So I2 we will take, that is 3x plus y and dy. So now we have to solve it just like first one, 3x plus y dy plus C2 3x plus y dy plus C3 3x plus y dy. Now we have to look at the limits again. So I will put the limits in the first curve, z is equals to 0, and x goes from 1 to 0, and y goes from 0 to 1. So we have dy here. So this time we are going from 0 to 1, and 3x plus y dy. So we have dy, so let's consider convert the x into y. So this will become 3 into 1 minus y plus y and dy. Next, for the C2, we will have dy here. So 3x plus y. In this case, x is equals to 0, y goes from 1 to 0, and z goes from 0 to 1. So we have y, so 1 to 0. And we have 3x 0 plus y dy, because x is 0. It has deleted something here. So let me find it, what I will. 3 into 1 minus y plus y. Okay. For the third curve, we have y is equals to 0, and z goes from 1 to 0, and x goes from 0 to 1. So we have dy, so this is 0. So this term is 0. So let's go solve these ones. We have 3 minus 3y plus y, 3 minus 2y, and dy. Zero to 1, 3 minus 2y dy. For the second term, we have y dy, and it is going from 1 to 0. So this is coming from 3y minus 2y squared by 2, 0 to 1, plus y squared by 2, 1 to 0. So this will become 3 minus 2 to cancel. So we have 1 minus 0. Plus here we have 0 minus 1 over 2. So it will become 3 minus 3 by 2. So it is 3 by 2. For the last integral, we will write I3 equals 2y minus z dz. So again, I have written 2 times the limits, so you will find them. I just write the solution. So it is going to be C1 2y minus z dz plus C2 2y minus z dz plus C3 2y minus z dz. So for the curve 1, we have limit 0 because z is 0. For the curve 2, we have x is 0, y plus z is 1. So we will write it into the 0 to 1, z goes from 0 to 1, y will be 1 minus z minus z and dz. Oh, sorry, 2y minus z, yeah. For the third, we have 1 to 0. And this time our z is going from 1 to 0. We have y is 0. So this will become 0. We have minus z dz. So solving it, we get 2 minus, you can solve it, it's easy, fine. It is again 1. So our total integral is going to be I1 plus I2 plus I3, which is 1 plus 3 by 2 plus 1. It is again 7 by 2 solution, which also we got from the Stokes theorem. So any question about it? Welcome. So now we have done line integral, we have done Stokes theorem, so we have done the volume. Okay. There is a question on divergence theorem to calculate the outward flux of the vector field. Do you want to do that? The region is bounded by some, yes, please, okay. So let's do it. So this is question number 6 in the exam. So I will write it here, question number 6. Using divergence theorem, find the outward flux S F dot NDS of the vector field F is equals to 2x plus e raised to power y plus z I unit vector z square minus 2yz j unit vector plus x square plus z square k unit vector. D is a region bounded by y is equals to x square, z is equals to 4 minus y, and z is equals to 0. So this is what we are given. So we have to apply divergence theorem. Okay. So let's write its solution. So divergence theorem is F dot NDS equals D, and divergence of F dot dV. So gradient del dot F we find. So this is going to be partial over partial x into 2x plus e raised to power y plus z plus partial over partial y of z square minus 2yz plus partial over partial z x square plus z square. So when we solve it, this one, we get 2 from here. From here, we get -2z. And from here, we get 2z. So they will be cancelled. We have 2. So our del dot f is 2, divergence is 2. So now we will go to the 2 dot dv, we will find it. So 2 is constant, come outside. So this is the one we want to find. For that, we need limits, fine. So this is the simple calculation we did. Now we have to use our boundaries. So let's look at the boundaries. Boundaries are y is equals to x square. Fine. So this is our y-axis. This is our x-axis. And this is z. So y is equals to x square. So it means when y is equals to 2, x is equals to 2, y is equals to 4. Right? This is 2. 1, 2, 3, 4. So y is equals to 4 when x is equals to 2. And so the point will be here somewhere, fine? This is 2, 4. And we have z is equals to 4 minus y. Z is equals to 4 minus y. So when y is 4, z is 0. So here, z becomes 0 when y is 4. So here is z is 0. And then here. And when y is 1, y is 3, z is 1. So it is values here. So we find that this is going like this. But this is the point in the xy plane where we are going to adjacent it. So this should mix it with this one. So this is the point where it should be. Then we have z is equals to 0 and y. So y is equals to x squared. So what we are finding here, this is the point. Let's mix it when x is equals to 0, y is equals to 0. So this is the thing we are going to find. Okay, you got it? Yes, okay. So let's find our limits. X is going from, if you look here, x is going from 0 to 2. Zero to 2. Y goes from x under root, because y is x square and x is equals to y square. X square, sorry, y is equals to x square. So x under root, it will go to 4. And z will go from 0 to minus 4 minus y, which is we are given. So let's put the values. Check again if you find any problem, just consider it. Okay, tell me as well. 0, 4 minus y. So here we have dz, dy, dx. This is our y, this is our x. Now it's just we have to solve it. So z going from 0 to 4 minus y, dy, dx. Here we have y and x. So it will be 4 minus y, dy, dx. This will be equals to 4y minus y squared by 2. And we have the terms x under root to 2. This is dx, and this is x equals to 0 to 2. So here x, y. So please don't do it exam. Be carefully finish everything. I'm scared that pen will stop working, so that's why. So x is equal to 0 to, we have this value, we have 4 to the 8. Eight minus 4 by 2 minus, it should be 4. It should not be 2. It should be 4 here. So let me write again. This is going to be 4 by multiplied by 4 by 16 minus 16 by 2 minus 4 under root x minus x over 2. So this is our value. So let me write it on this side. It is going to be 16 by 2 minus 4x under root plus x over 2. Okay, this is dx, and this is 0 to 2. So now it is easy to solve. We will get 34 minus 16 by 3 2 under root 2. This is the solution. Any question? Okay, welcome. So now let's look what kind of questions you have done. Find the points on the surface at which the tangent plane is parallel to the xz plane. Can some such kind of question can come? That is a good question. Okay, we can find a button as well. So let's do these two questions. Okay. So what I'm going to do is the 8th question. Find the points on the surface x square plus 6y square plus 3z square minus 3xy equals 9, at which the tangent plane is parallel to the xc plane. Okay, this is the question. So our tangent plane is parallel to the xc plane. This is xz plane. If this is x, this is y, and this is z. So this is. So it is parallel to this, fine. X square plus y square plus z square minus 3xy is equals to 9, which is given to us. So our function of x, y, z, we can write it as x square plus y square plus z square minus 3xy minus 9, which is equals to 0. This is our function of three variables, 3D function. So first we will find the gradient of f, which is going to be partial f over partial xi unit vector plus partial f over partial y j unit vector plus partial f over partial z k unit vector. So our f is that one. So we will have 2x minus 3y I unit vector. Why we have 3xy? So look here, this is x square. So it is differentiation 2x minus 3xy. Differentiation is minus 3y. So that's why I write that. Similarly, we have 2y minus 3x j unit vector plus 6z k unit vector. So now normal to the tangent plane means normal to surface plane, okay, where they touch. So we will find the normal to the tangent plane. So as our tangent plane is along xz, so it means our normal is along y-axis, fine. So our normal is along y-axis. So you got this point, as tangent is along x, z plane. So we have a point 0, 1, 0. So this is our point. Now let's see, z is equals to 0. Okay, and we have 2x minus 3y equals 0. Just 1 minute, why I write this thing. So we are talking about xz plane, and 6z is equals to 0. Okay, so this gives us z is equals to 0, and we are talking about here, so y comes here. Two by 3x. Let's put these values, x squared in our function, x squared plus 6 into 2 by 3x, and equals to no question. 2 by 3x squared plus 0, because that is 0, minus 3x into 2 by 3x is equals to 9. 3 cancel, and 2, so we have x squared. No, this is 9, sorry. So it is not canceling it. Sorry, I made a mistake here. This is 3 square, so this is 6. So we have 4 over 9, and this is 6. So it will become 8 over 3 x squared minus 2x squared equals 9. This will give us x is equals to plus minus 27 over 5 under root, which is equals to plus minus 3 under root 3 over 5 under root. So now check that if x is positive from here, if x is positive, y is positive. If x is negative, y is negative. So our points will be plus 3 under root 3 over 5 under root. Our y will be, so let's find first y. Y is equals to 2 by 3 into 3 into 3 under root divided by 5 under root. So we have 2 3 under root over 5 under root. So our points, let me write the points below. Our points will be 3 under root 3 over 5 under root, 2 under root 3 over 5 under root, and z is 0. First point, and second point is going to be with these minus. Minus 2. So these are the points where the surface will touch. Any question? So we have 10-20 minutes. Let's do find the work done by force acting along the helix. Would you like to do that? Sure. Okay. Sure. Fine. So this is the question number 10 in the exam. Find the work done by a force. Force is given as F. X, comma Y, comma Z. This is 8xy squared, I unit vector, plus 12x squared y cube, j unit vector. So it is y squared. Plus 4x squared y cube. A unit vector. This is our force. And acting along a helix. Helix is given as RT is equals to 2 cos of t unit vector I plus 2 sine of t j unit vector plus tk unit vector. And it points goes from 2 0 0 goes from 2 0 0 to 1 2 2 pi. In the exam, there was a question, there's a mistake in the question, so I am going to use these ones. Sorry. So hopefully it is working. Not gone everything. Yeah, hopefully it's there. I think we missed something here. Yeah. So one question is gone, but let's do this one. So I will send you the notes, okay, which I have written, so I don't have to write everything again. So F is 8xy squared. Let me write it in the blue. I'm going to write the solution now. F is equals to 8x squared. 8x squared y I unit vector plus 12x squared y squared j unit vector plus 4x squared y cube k unit vector and RT is 2 cos of t I unit vector plus 2 sine of t j unit vector plus tk unit vector. So dr by dt will be minus 2 sine of t I unit vector plus 2 cos of t j unit vector plus k unit vector, because t will become 1. So usually we have our x f is in x y z, so our r is usually xi unit vector, which is a function of t, y which is the function of t, j unit vector, plus z which is the function of t, k unit vector. So comparing both are, okay, this is 1, this is 2, and let me write the above one. So this is our 1. Okay, comparing 1 and 2. We get x is equals to 2 cos of t, y is equals to 2 sine of t. This way it will be easy to write. And z is equals to just t. So we have find our x, y, z, and we will put them in the function. So f will become 8 into 2 cos of t, 2 sine of t square I unit vector plus 12 2 cos of t square 2 sine of t square j unit vector plus 4 into 2 cos of t square 2 sine of t cube k unit vector. So this is our f in t format. So we will, I will write the final result. This is 64 cos of t sine square t I unit vector plus 192 cos square t sine square t j unit vector plus 128 cos square t sine cube t k unit vector. So this is our f. Now we have to find f dot dr. This is in the format of t. Z is t. So we will take the limits of z, which is going from 0 to pi. With the limits given to us, they are 0 to pi. So 0 to pi, and we have multiplying it with dr, we will have, this is minus 2 and this is 64. So I will write the result. You can multiply them by yourself. Minus 128 cos of t sine cube t plus 384 cos cube t sine square t plus 128 cos square t sine cube t, and this is dt. So when you will solve it, you can use substitution, okay? Sine t is equals to u, or cos t is equals to u, and cos t dt is equals to du, like this. So you can solve all these terms, and I will write the solution here. So where did I write the solution? Okay, so let me check my solution again. Sorry. Oh. I think it is misplaced, so you can solve it from here. It's easy. It's not that difficult. It's okay. So I hope you got something, it was helping for you. So if you have any question, let me know. Welcome. So if you don't have question, then let's finish it. Already we are done, and I think there's no more other question which will help you more. But if you have any question, can you show the recommended problems? Which have been recommended to you? So I got the problem. You guys gave me the recommended problems. I did not have them, but if you have any question about it, just let me know. I will try. If I could solve 2 or 3 questions, I will add to the notes. Okay. So just tell me which question you want to do. Like in the 9.15, there are so many questions, 3, 7, 9, 13, 15, 17, 21. So it is not possible for me to do all of them. But if you have any question, particularly you are solving it and it is not doing, show me your solution and I will help you with that. Welcome. Okay, then I'm going to stop sharing and I will send you the solutions.